Good afternoon, students. Today's topic is vector and scalars. This is our first lecture on vectors. So what is a vector? Vector is a physical quantity having magnitude as well as direction and obeying the law of vector addition. This is very important. This obeying the law of vector addition. There are few quantities which have direction as well as magnitude, but they are not vectors. For example, current. Current is a scalar quantity as opposed to current density, which is a vector quantity. I'll come to that later. So this obeying the law of vector addition is important, but the problem with this thing is I am using a law of vector to define vectors, but I can't help it. So anyway, so obeying the law of vector addition, I have to add. Okay, and what's a scalar then? A scalar is a quantity which have only magnitude. Examples of vectors? Examples, well, velocity have a magnitude as well as a direction. Displacement, current density. You will get to understand this when you go to class 12. Current density, force, acceleration, etc. So these things are vectors. There are a lot of quantities which are vectors. Scalars, well, mass, temperature, color intensity, these are scalars. You don't have a direction as far as this quantity is concerned. If you grow and as you age, you will see that the definition of vectors and scalar transforms a little bit. You will define vector in the form that vector is a quantity which obey a particular transformation law. So as far as in your plus 2 level is concerned, keep these definitions as the definition of vectors and scalar. And there is another quantity I must mention. It's called tensors. In fact, tensor is a quantity which has rank, means a tensor of rank 1. A tensor of rank 1 is a vector, and rank 0 is a scalar. There are few quantities which have rank 2. They are neither vectors nor scalar. They are specifically tensors. For example, pressure. Pressure is a tensor quantity. Normal pressure is not a tensor quantity. Normal pressure is a scalar quantity. I tell you one thing, I must add another example with this. Suppose area. Area is a vector quantity. The direction of this area is perpendicular to this area. The magnitude is the area of this thing. So area is a vector quantity, and force is also a vector quantity. I am mentioning particularly these two because to bring pressure into the picture. So tensor, pressure is a tensor quantity, tensor of rank 2. Because there are two things involved. One is the area and other is the force. If it is normal force, that is thrust by area, then you don't have an option to choose a component, then it's a scalar. So normal pressure is a scalar, but if you consider pressure in general, so it is a tensor quantity, because this area can move, rotate in our 3-dimensional space, and this force can also move in 3-dimensional space. If you give a tangential force, it is a shear, and if you give a normal force, this is a no, thrust by area, that's pressure. So two vectors are involved here. It's neither a dot. It's the combination of these two vectors makes a tensor. So pressure is a tensor of rank 2. Tensor of rank 2, but I must not mention too much of these things. Anyway, you will get to understand as you age. Now let me go into the vectors first. We need to mention the representation of a vector. How do you represent a vector? Okay, so okay, vector representation. See, representation of some physical quantity is very important. How do you represent a vector? Representation means, for example, suppose you are moving very fast. You are moving very fast. So in the same in a particular direction, and another person is moving faster than you. So the direction of both of you, suppose two runners, right, moving side by side. One is moving a little bit slower and other is moving a little bit faster. So how do you differentiate? Both are having a same direction. See, so the direction comes into a picture because they're moving in the same sense, same direction, but one is moving faster than the other. So this fellow is moving faster, right? Usain Bolt is moving faster than this person. So suppose this is v vector, and this is suppose this is v1 and this is v2. So v2 is greater than v1. So that means this arrow automatically gives you a feel that this magnitude of this velocity is greater than this velocity. But technically, how do you put it on the board? That is very important. For example, suppose a person is moving with a speed of 10 meters per second and this fellow is moving with a speed of 9 meters per second. So 10 meters per second, this board is only less than 2 meters. This is 4 feet, even less than 1.5 meter. So how can you can't place a big arrow in this board, right? What do? You scale it down. How do you scale it down? Well, suppose this is a scales. This scale is important. You have learned it in school. Suppose in all geography atlas books, you have suppose there is a world map, right? And suppose here is a map of some. Suppose here is some continent, and you are given the distance between these 2 points. So these 2 places. In the right side below, you will find there is a scale. Right, there is a scale. Suppose this is 0, suppose this is 10,000, suppose this is 20,000 kilometers. So how do you do? What do? You just measure this length. This length is actually 10,000 kilometers, right? This length, suppose this length is L. And suppose this is 0.8 L. So this is 0.8 L, 8 by 10 times L. So what is this distance between these 2 points? Okay, if this L stands for 10,000 kilometers, so this too must be 8,000 kilometers. So what do? You can easily make out the distance between these 2 places is 8,000 kilometers, right? So that's how you scale it down. Very similar, you do the same thing in vectors. For example, suppose here is an arrow and suppose how much this length is. Well, this is 1 feet. Well, bring it in centimeters. Suppose this is 30 centimeters, right? So, and suppose this is v2 is 10 meters per second. So, if I want to find the scale from this arrow itself, and suppose this is 9 meters per second, right? Let me increase a little bit. Well, suppose this is 30 centimeters, right? If this is 30 centimeters, so 30 centimeter stands for, well, 10 meters per second. So 1 centimeter stands for unitary method. 1 centimeter stands for 10 by 30 meters per second. So then how much 9? This is 9 meters per second. So what should be the length of this? What should be the length of this arrow? I must go the other way around. Actually, this is the scale. This is the scale. This is the scale. But if you actually go the other way around, suppose 10 meters per second is represented by, just change the language once you swap those meters per second and centimeter. 10 meters per second represents or represented by 30 centimeters. So then 1 meters per second represented by 30 by 10, that is 3 centimeters. So 9 meters per second represented by 3 into 9, 27 centimeters. Bring another fellow. He is moving with a speed of suppose 8 meters per second. So what will be the length of this arrow? Naturally, 1 meters per second is represented by 3 centimeters. So 8 meters per second is represented by 3 into 8. So that is 24. Let me use a different color. So this is 24 centimeters. This is 27 centimeters. And this is 30 centimeters. So representation means you must have a scale. If you don't have a scale, from this arrow you will not be able to make out what is the magnitude of the vector, right? So representation means you must have a scale, and from that scale you must multiply centimeters. So suppose this is 30 centimeter, right? So 1 centimeter stands for 3 by 30 meters per second. So that is how much? 1 by 3 meters per second, right? So if you multiply 30 into 1 by 3, so that you get 10 meters per second. So that is the representation of a vector. Fine. Now I will come to vector addition a little bit later. Let me define scalars a little bit. What is a scalar? Scalar, well, scalar is a quantity which has only magnitude. You don't have directions, so you don't need to worry about that. The mass is a scalar, color intensity is a scalar, temperature is a scalar. Anything which has just magnitude is current is a scalar. Current is a, suppose why current is a scalar. Let me give a little bit of, suppose you have a wire like this, right? And it has a direction, that's fine, but you can't have the component of current. You can't have a component of current somewhere in this direction. But the thing is, why velocity is a scalar? Suppose you place, suppose raindrops are falling, right? You place your hand like this, the raindrops will hit your hand hard. But if you place your hand like this, the raindrops will hit your hand not that hard. That means, suppose this is a velocity. You place your hand like this, right? So it's hitting hard. But if you place your hand like this, I'm not an artist, so forgive me for that. So it will hit, but a perpendicular component will be like this, and the tangential component, which is I'm not interested with, because that is not responsible for hitting you, because if you place your hand absolutely tangentially, the raindrops will graze. So the component picture is here in velocity. So some component is hitting your hand. In the case of current, there is nothing. If you don't touch the wire, you will not get a shock, right? So where the current is flowing like this, but current density, well, that's a different issue. I'll tell you, current density is a vector quantity. You will come to know in class 12. Okay, so current is a scalar quantity. Pressure is a scalar quantity. Normal pressure, not general pressure. General pressure is a tensor. I tell you why. See, as far as this is concerned, normal pressure means this is force, right? Force, and this is area. If you have a force in some different direction, then it's not normal pressure. So we are fixing the area and we are fixing the force. The direction is fixed. You can't have a component in some other direction. Since you don't have a component in some other direction, so then I can't have a vector like situation, right? So normal pressure is a scalar quantity. General pressure is a tensor quantity. You will come to know later. Never mind. This is an introduction to vectors. What is a vector? What is a scalar? And how do you represent a vector? In the next lecture, I shall go into how do you add two vectors, what is the method of addition of vectors, and how do you subtract a vectors, how do you multiply a vector with a scalar. So wait for the next lecture to come. Thank you very much.